Good morning, everyone, and welcome to my presentation. My name is Twarogowska, and I'm PhD researcher at the Flanders Research Institute for Agriculture, Fisheries and Food in Belgium. My research interest centers around the valorization of the streams from Cichorium. That's why today I will talk about the potential of the Belgian endive forced roots as a feedstock for the biorefinery concept and its valorization potential. Let me start with the short introduction of the Belgian endive. I believe that Belgian endive is not known very well for all of you, and especially the term forced roots can be quite mystery for most of you. So that is why I would be delighted to provide you with some more information about it, and hopefully after this part you will know what it actually means, the forced roots. Let's start. Belgian endive belongs to the Cichorium genus and is characterized by the pale yellow, tightly wrapped cylindric head of lettuce, known also as a chicon, and it's famous from their unique bitter taste. Belgian endive is an also economically important crop in Europe, especially in Belgium, France, Italy, Germany, and the Netherlands. The yearly production of the Belgian endive in the European Union is estimated at around 400,000 tons. The Belgian endive is grown in a three-step cultivation. Firstly, plants are grown on the open field for the production of the taproot. It's happened between May and October. The roots they are harvested and then they are stored in a cold. Depend on the cultivar, it can goes up to 12 months. The last step, where the forced roots are produced, it's called the forcing. It's a 21 days forcing process where the roots are placed in the hydroponic chambers or in the soil at the temperature around 16 degrees in the darkness. After forcing, the chicons are harvested from the roots and the roots are discarded. The forced roots of Belgian endive, they are considered as a byproduct with no high value used often with the feed for the compost of the animal feed. However, due to their chemical composition and they are really interesting feedstock for the biorefinery concept. They are rich in the sugars, mainly it's sucrose and the fructose with little amount of glucose, and oligosaccharides such as raffinose and stevia. They are also known for having quite substantial amounts of inulin, which belongs together with the pectins. They belong to insoluble dietary fibers and insoluble dietary fibers, where they are mostly cellulose, hemicellulose, and lignin. What is more, the forced root of Belgian endive, they are also rich in the bioactive compounds, mostly in the phenolic compounds, where they are predominant. They are the phenolic acid, and they are the hydroxycinnamic acid with the chlorogenic acid as the main one. And phenolic compounds, they are known to be very strong natural antioxidants. Another group of important bioactive compounds, they are sesquiterpenolactones. Sesquiterpenolactones, they are sesquiterpenoids that contain the lactone ring. And they are known to be responsible for this unique bitter taste of the crop and the roots. So, and besides this, they are also known from the broad range of the biological activities, such as anti-inflammatory, antifungal, antibacterial, and self-anti-malarial. That, as I mentioned earlier, forced roots of Belgian endive, they are very interesting biomass for biorefinery. They are stable during the storage, they are available year-round, and they are produced in a high amount, and the production is quite centralized. What is more, they have really interesting composition, chemical composition, which includes high sugars, dietary fibers, phenolic compounds, as quiterpene lactones. So therefore, thanks to the biorefinery concept, the nutrients can be recovered and used in a diverse, high value added products with a different application. After this short introduction about the Belgian endive, I would like to move to the next part of the presentation, where I will focus a bit more on the process and on the composition and the functionality, as well as the valorization potential of the produced dietary fiber concentrates and the spray dry powder. However, I would start with the shorter describing of the process that we used for the production of the dietary fiber concentrates. So our start material was the first fruits of Belgian endive that they were washed, cut in julienne forms, and later on soaked in water at 60 degrees for 2 hours, and the water was changed twice, after 1 hour and after 1.5 hours. There also steering was implementing, and the ratio of the root to water was 1:4. And each water fraction was collected separately, and as you can see, the solid fraction was separated from the liquid fraction by the use of the strainer. From the solid fraction, which is rich in dietary fibers, they were used to produce the dietary fiber concentrates. So after soaking, they were dried, and later on they will melt. The water fraction was, as I mentioned before, collected, later on was concentrated and used in the spray dry process, and we obtained the spray dry powder. However, in the next few slides, I will focus mainly on the dietary fiber concentrates, and then the spray dry powder will appear a bit later in the presentation. First of all, I would like to clear a bit explain the term dietary fiber concentrates, and actually which powders they can be considered the dietary fiber concentrates. So dietary fiber concentrates, they are the powders with a high content of the total dietary fibers, more than 50%. They are produced from the fruits and vegetable byproducts. They have the moisture content below 9%. They are neutral in taste. They are low in lipids and sugars, and they are used in the food formulations to increase nutritional value and improve the functionality of the end product. Knowing this and the characteristic of the dietary fiber concentrate, we can surely say that we produce dietary fiber concentrates. However, we know also that the process that we use, they have significant influence on the chemical composition and functionality of the first fruits. That's why, and here we presented the composition, not only the dietary fiber concentrates, but also the first fruits powders, which they are the powders that they were not soaked. So the roots, they were washed, cutted, dried in the oven and milled. That's what here, thanks of this, we can see how the profile of how the composition of the roots change after the used process. So as we mentioned before, the main sugars, and they are sucrose and fructose, and they are also oligosaccharides, stachyose and raffinose, and a really little amount of glucose. And as we see after the soaking process, so here in the content of the sugars in the dietary fiber concentrates was significantly decreased. around 90%. What it gives us the powder with a little amount of sugar, what it's desired for dietary fiber concentrates. The similar situation happened with our bioactive compounds, and the chlorogenic acid was thought the content of chlorogenic acid was significantly decreased. However, like the rest of the phenolic compounds, such as quinic acid, cichoric acid, caffeic acid, and 4-hydroxyphenylacetic acid. The same happened with the sesquiterpene lactones. The concentration in the forced roots powder, they were much higher than in the dietary fiber concentrates. And right now on the market, they're available for standards, thanks to what we could quantify them. And the rest of the present sesquiterpene lactones, which includes the lactocin, lactocopicrin, deoxylactocin, their dehydroderivatives, and oxalate and glycoside forms, they had to be profiled based on the relative peak areas. But the main conclusion is that as well the process, the soaking process, significantly decreased the amount of sesquiterpene lactones and phenolic acids. Someone could say they are important compounds that should be kept in the powder. However, these secondary metabolites, they're responsible for the bitterness and astringency that it's mostly negatively correlated with the consumer appreciation, and also make it much more difficult to implement this powder in the food formulation. That's why our aim was to decrease the amount of these compounds in the final dietary fiber concentrate. The high content of the dietary fibers, it's another characteristic that it's crucial for the powders to be named dietary fiber concentrates. And we noticed that the soaking process enhances the amount of insoluble dietary fiber and decrease the content of soluble dietary fiber, and it's mainly inulin. Because the inulin diffuse into the water during the soaking process. However, and we see that the total dietary fiber content increased from 49% to 81%. Here we presented some axes that shows the insoluble dietary fiber and soluble dietary fiber content of the other dietary fiber concentrates, which are the commercially available. That it's we give this for some comparison, that we could place it the concentration of dietary fibers of the produced from the Belgian endive. And the profile of the dietary fibers, of course, has impact also on the functional properties of the dietary fibers concentrates. And the functional properties of the dietary fiber concentrate are crucial for the determination of their use in the food formulation. The most common functional properties that they are characterized with the dietary fiber concentrates, they are water holding capacity and oil holding capacity, that actually they represent the capacity to trap water or soil in the matrix when they're exposed to the external force, such as centrifugation. While the swallowing capacity shows how well the dietary fiber concentrates, they absorb the water. So the processing condition used in our research increased the value for functional properties. So we can see that it increased from 5 gram water on the gram of the powder to 14, almost 15 gram of the water in a gram of the powder. The oil holding capacity was similar, stayed similar, the same, not significant improvement, and the swelling capacity was almost twice higher than in the case of the forced root powder. But probably it has to do with the dominance of the insoluble dietary fibers in the total dietary fiber profile, because the higher amount of insoluble dietary fiber is related with the better hydration properties, such as water holding and swelling capacities. Here we also prepared the axis with the different with the functional properties of the different dietary fiber concentrates which are commercially available. And with this, I would like to go more into the valorization potential of the dietary fibers as a functional food ingredient, and the application of the dietary fiber concentrate produced from Belgian endive forced roots into food formulations, and they have the biggest potential into bakery products, pasta, snacks, meat, like hybrid meat, veggie burgers or spreads. It can the main positive thing is that they could enrich them in the fiber, stimulating the fiber intake and minimalizing the gap between the current consumer fiber consumption and dietary fibers recommendation. Low sugar content and potential health benefits meet the demands of the consumers looking for clean labels, less artificial ingredients. So moreover, this prospective utilization of the byproducts could have a positive impact on the environment and promote a circular economy and sustainability. As I said before, I come back to our water fraction, and in our experiments, we stabilize this fraction by use of the spray drying. And spray drying is affordable way of drying and allows to obtain the stable product in a powder form. We analyzed the spray dry powder, where as we expected, we found sugars and oligosaccharides, phenolic compounds, and sesquiterpene lactones. And we also we saw that actually they are even enriched in a sesquiterpene lactones, and then the profile is also a bit different than in the forced root of powder. Forced root powder, but it can be because of there was extra of the steps of drying. However, we know that the powder is rich in sesquiterpene lactones, in the polyphenols, and also in the sugars. And here we also see that small change with the profile, where now the fructose is the main sugar. However, it can be related with the decomposition in the inulin in the elevated temperature during the processing. And with this, this would be, I would like to say about the possible application, which can be the spray dry powder, or just the concentrated liquid can be used in production of the beverages, such as where the bitter taste is appreciated, such as like gin tonic, tonic, and beer, and cosmetics due to the bioactive compounds and the biological activities. And also it can be used as a start material for isolation and purification of bioactive compounds, for example, such as keterpene lactones. And this leads me to my last slide, which is the short conclusions, where I would like to emphasize that the forest roots of Belgian endive, they're interesting feedstock for zero waste biorefinery concept. And the obtained fraction have a high valorization potential in food formulation and cosmetics. With this, I would like to thank you very much for your attention. And if you have a question, I will be really pleased to answer that.